in space and how it has developed over the 250 years of this nation's development and evolution. And as was mentioned, after the talk is over, after the presentation is over, you're very welcome to ask any question you would like by simply unmuting yourself, or maybe you just simply would like to put a comment or a question up on the Zoom chat board. But right now, what I'm going to do is I'm going to go through the machinations here of sharing my screen with all of you. This is a PowerPoint presentation, and I'm doing that right now. And we will go starting from the beginning, which is a very good place to start. And away we go with Yankee Stargazers. Now, first of all, I'm sure that you are all aware by now that we are celebrating the 250th anniversary of the birth of this country. The adoption of the Declaration of Independence came on July the 4th, but not the signing. Believe it or not, the signing came some weeks later. On August the 2nd is when people began to sign the Declaration of Independence, kicking off with John Hancock's signature. So it was the adoption of the Declaration in 1776, July the 4th, and this 250th anniversary is being referred to as the semi-quincentennial. Some of you of a certain age may remember that back in 1976 we were celebrating the bicentennial. Well, now we have, 50 years later, the semi-quincentennial. Anyway, we're going to talk about space and science and the evolution of that through the years. And since the very beginning, also let me just say one other thing. Periodically, during the next hour, you'll hear me stop talking for about 5 or 6 seconds. And the only reason why I'm doing that is that, I don't know how many of you can still see me there, but I will be taking a sip of ginger ale to help to lubricate my throat, which I'm going to do right now. And now we will start the presentation here. From the very beginning, science in general enjoyed a prominent place in colonial America. Harvard College was founded in the year 1636. That was just 16 years after the first settlements in Massachusetts. Now, from the start, natural philosophy, that is what we know today as science, had its niche in the curriculum next to moral philosophy, metaphysics, languages, and rhetoric. Now, interestingly, from the beginning, and rarely mentioned, is the fact that at the time of the signing of the Declaration of Independence back in 1776, astronomy was the most highly developed of all the natural sciences. Physics was considerably less developed than astronomy, but still ahead of the other natural sciences. Chemistry, in the modern sense, did not yet exist. Chemists did know how to make certain substances, mostly for pharmacological value, but that was about the sum total of their knowledge. Electricity had yet to be discovered, although there were a few electrical phenomena that were known at that time. Zoology and botany were still in the state of collecting specimens and information without much understanding of either natural relationships or biological functions. Meteorology was a thing of the future, and geology was likewise. So was metallurgy. Medicine fumbled, and in fact, surgery, if you were unfortunate to need surgery back 2.5 centuries ago, surgery was really nothing more than a stage of benevolent torture with only occasional successes. Geography was doing fairly well, but still had enormous gaps to fill, comprising most of the interior of Africa and virtually much of the area of the world below the equator, much of the southern hemisphere. But astronomy in particular was cultivated both in and out of the classroom. The reasons are many and complex. For one thing, astronomical knowledge was needed in everyday life in order to navigate the oceans, survey boundaries, chart the wilderness, and even tell time. The ordinary person was probably more familiar with the heavens in 1700s than they are today. Now, the gentleman you see on your screen here was John Winthrop Jr., And John Winthrop Jr. was the governor of Connecticut, and he brought America's first notable telescope to the New World in 1663. It was about 3.5 feet in length. You see it behind him. And as is often the case today, politics and administration leave little time for the practice of astronomy. So in 1672, Governor Winthrop presented the telescope to Harvard, where it might be put to more use. During the history of that telescope, in 92-year history, the Winthrop telescope had many distinguished guest observers, including the remarkable Increase Mather and his precocious son Cotton. Both wrote extensively on theological, historical, and scientific subjects. Both were Puritan clergymen and authors in colonial New England. Now, sadly, the Winthrop telescope met its end, an abrupt end, on the night of January 24th, 1764, when a catastrophic fire ravaged Harvard Hall and destroyed nearly all of the scientific books and apparatus that it contained. Now, here you see a telescope, a 15-inch telescope. The front of the telescope, the lens measured 15 inches in diameter, and it became known as the Great Refractor. It was installed in Cambridge in 1847, and for 20 years, it was the largest telescope in the United States, the most significant American astronomical instrument, and equal to the finest in the world. It formed the nucleus for development of the Harvard College Observatory. Now, we all know that February sometimes involves a leap year, but in a little quirk of history, American colonists once had to leap weeks into the future. The British, and by extension the colonists, waited until 1752 to make the jump from the calendar that was originally created by Julius Caesar in 45 BC. That was the Julian calendar. And then much, much later, a new calendar was commissioned by Pope Gregory the 13th, and that happened in 1582. The Gregorian calendar is our current standard. And they landed about 11 days off the mark. You see here that when the Gregorian calendar went into effect in Europe, you see the first 4 days of the month of October 1, 2, 3, and 4. Thursday, October 4th, there was a 10-day discrepancy between the Gregorian calendar and the Julian calendar. They needed to get those 10 days in to get the calendar back in step with the seasons. And so, after Thursday, October 4th, came Friday, October 15th. Now, that was in Europe. As I said, the people in Great Britain and the colonists here in what was soon to become the United States did not make the transition until 1752. So as you see here, 1 second after midnight on September 2nd, 1752, it became September 14th. Of course, all birthdays followed suit, including George Washington's. Now, today we celebrate Washington's birthday. That's a Monday holiday, but Washington's birthday actually occurred on the 22nd of February, 1732. But when Washington came into this world and he was born, if there was a calendar hanging on the wall when he was born, February 11th, 1731 is what that calendar read, because they were still following, again, back in those days, the Julian calendar. George celebrated his 20th birthday on February 22nd, which is the date that we use today. Now, back in the day, back in the 1700s, in the American colonies during the 17th and the 18th centuries, the almanac stood next to the Bible in importance to daily life. It gave the times of when the sun and the moon set, the times at which certain stars would reach their highest points in the sky on different days of the year, lunar phases, the aspects of the planets, some astrological lore, and some Earth-based information, such as the condition of the principal roads between cities, tips on husbandry, and of course, weather predictions. Now, by the time we got to the early 18th century, by the time we got to, let's say, 1700, there was a cutthroat competition. A best-selling almanac could support its printer well into the year ahead, but he continually had to fight off counterfeit publications bearing the same name. Now, one of the hottest selling ones of the 18th century was Benjamin Franklin's Poor Richard's Almanac, which was published in Philadelphia. In mid-century, the 1750s, that almanac, published by Benjamin Franklin, sold between 50,000 and 100,000 copies annually. And that was in a country with a population of about 2.5 million people. And by the early 18th century, colonial Americans were beginning to contribute significantly to European science. In astronomy, astronomical contributions were accounts of a variety of astronomical phenomena. And these phenomena, now remember, this is the 1700s. Photography did not exist. And so what we had to rely on were people with good telescopes and very good artistic skills to sketch what they saw through the telescopes. What you're seeing on the screen right now is a sunspot, a close-up of a sunspot. It was thought back in the day that sunspots were holes in the surface of the sun. No, not really. Sunspots are actually giant magnetic storms that occasionally sprout or pop up on the photosphere, the surface of the sun. The surface of the sun is 11,000 degrees Fahrenheit. Sunspots, magnetic storms, they're cooler. They're only about 7,000 or 8,000 degrees Fahrenheit. So when you put a sunspot up against the bright surface of the sun, it looks dark because it's several thousand degrees cooler, and that gave the impression that the sun had a hole or a large spot on it. Again, here you see a view of the sunspot, and you can almost see the magnetic curls, if you will, the magnetic fields amidst the sunspot in this particular rendering. There were also renderings of our nearest neighbor in space, the moon. What an exciting object that was. The moon with its mountains and valleys and craters. It was always an amazing spectacle for many to look through their telescopes and on up to the moon. And I'm sure that not a few people who looked wondered what it might be like if we were able to go to the moon, if we were able to physically walk on the moon. Pure science fantasy back in the 1700s, but as we all know, eventually that fantasy came true, as we will soon see a bit later in this presentation. And then there were the planets. Mars, oh, Mars. Right down through the ages, Mars, a fascinating object to look at because of its ruddy color. Mars, then seen through the telescopes of the Italian astronomer Schiaparelli in 1877. Mars, which seemingly had, well, lineations, lines crisscrossing its surface, which Schiaparelli, an Italian, referred to as canale. Now, what he was trying to say was channels, but canale, ever hear the old saying, something got lost in the translation? Well, canale, when it was translated here in America, turned out to be canals. And there's a very important difference between channels and canals. Channels can be a natural phenomenon, but canals, they had to be made, and somebody had to make them. And therein lied the beginning of people thinking that Mars was inhabited by beings, intelligent beings, Martians. And again, it all started because of a mistake in translation of the word canale. And a lot of people were wondering, would we ever somehow manage to go to Mars? Well, we have landed on Mars, but again, that was a fantasy that would be many, many years into the future. Other planets, giant Jupiter. Oh, we've been able to look at that now through from spacecraft that have come up so close and have been able to get magnificent views, not only of Jupiter itself and the clouds that conceal its surface, but also of the amazing satellites that Jupiter possesses. This is an artist's rendering of what Jupiter looked like through the telescope. You see the great red spot. You see the cloud bands consisting mostly of ammonia. And also, you see two of the moons of Jupiter, casting two dark circular shadows onto the cloud tops of Jupiter. and the rings of Saturn. Oh, I don't know how many of you have had the opportunity to actually see Saturn's rings in a small telescope, but I tell you, if you have not had that pleasure, the next time you get a chance, please do yourself a favor and look, because they seem to glow with an inner light. Oh, it's of course because the rings are illuminated by the sun, and they're not solid disks the way they appear, but rather particles of matter about 10 miles thick, and the particles from within reflecting sunlight even as the particles near the surface do, causing the illusion of an inner glow as they gaze through our telescopes at these rings. There are other objects like the Great Nebula in the constellation of Orion, a giant cloud of gas. And it's not just a cloud of gas, it's actually a celestial incubator, if you will. We have actually seen stars being born inside of this cloud, because when you squeeze gas really hard, it gets hot, and eventually the gases climb to over 1,000,000 degrees, and a star is formed. As the thermonuclear reactions of fusion become spontaneous, a star lives. This great cloud, which is visible in the constellation of Orion, is so large it would take a beam of light about 26 years to go from one side of it to the other, traveling 11 million miles every minute of those 26 years. Other strange objects that appeared in the sky periodically or occasionally were comets. They look like, well, nothing like any other thing that they could see in the sky. Comets look like stars with a long appendage trailing behind it, a tail. And ancient people looking up at these comets thought that they were called hairy stars. They also thought that comets were omens of evil. There's an ancient jingle: 8 things there be a comet brings when on high at the hard range: war, famine, plague, death to kings, wind, earthquake, flood, dire change. So when a comet appeared in the nighttime sky, and a bright one like this that you're seeing here on the screen would appear about on average once or twice every 20 or 25 years, a comet was thought to be a signal that something disastrous was about to happen. In fact, the word disaster literally means bad star, taken again from the apparition of a comet. Other mystifying sights in the sky the ancient observers saw. Occasionally, they saw something that made them think a star had fallen from the sky. We call them meteors today, although the term falling star and shooting star are widely used. They are actually little bits and pieces, mostly no larger than pebbles and sand grains, that crash into our atmosphere at speeds of 30 or 40 miles per second. Friction with the atmosphere raises those particles to white heat, and behind the particle, it leaves an incandescent trail of light for a second or two, giving the illusion that a star had fallen out of its place in the sky. And sometimes we have tremendous eruptions on the surface of the sun, eruptions which we call solar flares. They spew out subatomic particles into space that move at the speed of 2 or 3 million miles per hour and reach our planet Earth after 2 or 3 days. These particles, these magnetic and subatomic particles, crash into our atmosphere high above our heads, interact and crash into and collide with molecules of oxygen and other molecules, and the collision forms light. And we see that light in the sky as what we call the aurora borealis, or northern lights. They're usually confined to the North Polar regions and South Polar regions. Places like northern Canada and Alaska see them frequently. We here in the New York area don't see them very often. At the latitude of New York, aurora are visible only about maybe once or twice a decade. You may remember 2 years ago, there were a whole bundle of very strong solar disturbances, which were strong enough to push the zone of visibility of aurora all the way south into our area. And so in May and again in October of 2024, we here in the New York area were treated to a display of the northern lights. Again, it doesn't happen very often, but when it does, What a magnificent display, what a beautiful array of lights it can cause in the northern part of the sky. Now let's get back to our old friend Benjamin Franklin. Ben was an author, a printer, a politician, a diplomat, inventor, and a scientist. He represented the unschooled original thinker and inventive genius so characteristic of so many early Americans. Now, among his scientific interests was astronomy, and he no doubt was eagerly looking forward to the night of November the 1st, 1743, when a total eclipse of the moon was going to be visible from his home city of Philadelphia. Totality would occur at a very convenient time, just after 9 o'clock in the evening, and the total phase would last an unusually long 100 minutes. Unfortunately, a spell of weather, unsettled weather, dashed his hopes and everybody else in Philadelphia, preventing them from observing the eclipse. From what we can gather, a full-fledged nor'easter, or possibly the remnants of a hurricane, blew in just before the eclipse was to get underway, complete with clouds and heavy, windswept rains. Sometime later, Franklin received a letter from Boston from one of his brothers, and the letter contained surprising news. The brother told Franklin that the lunar eclipse was seen there in Boston in perfectly clear skies, and the stormy weather that Franklin described that blocked his view of the eclipse didn't arrive until after it finished. Now, Franklin was very perplexed. He felt that because the winds in Philadelphia were blowing strongly during the storm from the northeast, and that was in the direction of Boston, that this was where the storm originated. This puzzled me, he wrote, because the storm began with us so soon as to prevent an observation of the eclipse, and being a northeast storm, I imagined it must have begun rather sooner in places farther to the northeastward than it did in Philadelphia. Now here you see what the weather map probably looked like on the day of the eclipse. You see that there likely was a storm off the mid-Atlantic coastline. And in this zone here, you see the area of wind, of clouds, of rain, which enveloped New York, enveloped all of New Jersey, Philadelphia, and all the way down to Maryland and Baltimore, and down into the mid-Atlantic area. This is where the cloudy, wet, windy, rainy weather occurred. But look at this. Here's Boston. Boston was out in the clear, just as Franklin's brother had described. So it was pretty amazing to Franklin, because he thought because the winds were coming out of the northeast, that was the direction where the storm originated from around the Boston area. But no, that was not the case. So Franklin began gathering weather observations from around Philadelphia and other locations, and eventually he determined that the proper direction of movement for storm systems was not out of the north and east, but from the south and west. In a letter in 1749 to clergyman Jared Elliott, Franklin pointed out that storms apparently occurred earlier in the regions toward which the wind is blowing. So if a wind is blowing from the northeast, it is blowing toward the southwest. And it began later for places in the direction from where the wind was emanating from. He would then write a treatise, a report on the behavior of coastal storms along the Atlantic seaboard. And to think, this all began because he was deprived of a view of a lunar eclipse in 1743. So, remember I said earlier, meteorology was a mystery. It was Ben Franklin who started to unravel that mystery and was the first to point out how weather systems move across the continent, across the United States. So he might have been, Benjamin Franklin was, perhaps the very first weatherman this country ever knew. Now, another eclipse of importance occurred in the year 1780. Samuel Williams was a professor at Harvard, and he led an expedition to Penobscot Bay in Maine to observe a total eclipse of the sun that was to occur on October 27th, 1780. But, as I take a sip here, just a moment, the eclipse was going to occur over Maine, over Penobscot Bay. But as it turned out, the eclipse was taking place during the Revolutionary War, and Penobscot Bay lay behind enemy lines. Fortunately, the British, believe it or not, granted this English expedition, the American expedition, safe passage. They said, no, we're not going to bother you. You're the enemy, but we're not going to bother you. And they cited the interest of science above political differences. Can you imagine if that were to happen today? Highly doubtful. But in 1780, the gentlemen from Great Britain put aside their political differences and said, no, go ahead, observe this special event, this special celestial event, this eclipse of the sun. And yet, in the end, all of that was for naught, because Williams apparently made a fatal error in his computations and inadvertently positioned his men at Islesboro, outside the path of totality, and likely finding this out with a heavy heart when the waning crescent of sunlight slid completely around the dark edge of the moon and started thickening. That is what Samuel Williams saw. He did not see a total eclipse because, again, he placed himself outside of the totality path. So the sun got smaller and thinner until it reached about this phase, and then the crescent began to widen, and the chances of seeing a total eclipse had come to a complete end. Williams, however, did make use of that observation, pointing out that what he saw was, well, it looks like little tiny dots of light. What it was, the edge of the moon, being mountainous and filled with valleys and craters, the edge of the moon is sort of like a serrated saw. So when the final little bit of sunlight disappears behind the moon's edge, it appears as beads of light. Many years later, another person by the name of Francis Baily would write about this phenomenon, and it became known as Baily's beads. But Francis Baily was not the first one to see them. The first person to see them and to make an observation of it was Samuel Williams in 1780, because again, he had made a boo-boo, made an error, and inadvertently put himself outside of the path of the total eclipse of the sun. Now, in applying astronomical knowledge to useful causes, no American succeeded more than Benjamin Banneker and Nathaniel Bowditch. Now, let's start with Banneker, who's on your screen right now. He became a celebrity in Tidewater, Maryland, at the young age of only 22, when he constructed a striking clock made entirely of wood. That the clock could be built, and indeed worked, was considered quite amazing, quite remarkable by his neighbors, not just because he was an impoverished farmer, but also because he had modeled his clock after a watch that he had only borrowed just once, and whose workings he had memorized. So here, this gentleman, at the young age of 22, took a look at a watch that he borrowed, memorized the insides of the watch, the workings of the watch, and then strictly from memory built the clock that you see on the left there, a wooden striking clock, which again made him a celebrity of sorts. Now, at the age of 58, and that was a ripe age for anyone who lived in the 1700s, I might point out. Not too many people lived much beyond 60 back in the 1700s. But at the age of 58, Benjamin Banneker was introduced to astronomy by books and instruments that were led to him by his prestigious neighbor and benefactor, George Ellicott. His mathematical and astronomical abilities developed at an extraordinary rate for a man of his years and positions. Banneker's mastery of difficult astronomical techniques catapulted astronomy into the public and political domain. His first astronomical work was an unpublished almanac for the year 1795, circulated by the Maryland abolitionist movement, led by the 60-year-old African American being named to the surveying team assigned to the task of determining the borders of the nation's new capital on the Potomac. In other words, at the age of 60, this man, this black man, Benjamin Banneker, was among those who were able to survey properly and make new property lines for the brand new capital, what would soon be the nation's capital, which we call today Washington, D.C. Philadelphia was the first capital of the United States, but now Washington, D.C. was to be the new capital, and Benjamin Banneker, using his knowledge of astronomy, became again the lead person to lead the surveying team that was assigned to the task of determining the borders of the nation's new capital on the Potomac. That survey and the 7 almanacs he later published demonstrated his proficiency in 2 of the areas where astronomy was considered adaptable to the nation's goals. That the thirst for knowledge is not limited to youth, and that the process of learning recognizes no barriers of race or creed. Now, at the Smithsonian Museum, the Smithsonian's National Museum, in the area of African American history and culture in Washington, D.C., you would find a statue of this great man, Benjamin Banneker. I'm sorry to say that if you were to go to Washington and go to the Smithsonian to seek out this statue today, you would not be able to, because, and I shake my head when I'm saying this, but the current administration feels that this particular department, the National Museum of National American History and Culture, is, well, a word they call woke. And so the great statue that you see here of this great man, Benjamin Banneker, who again was able to be the lead surveyor in setting the boundaries of what is now our nation's capital, is no longer on exhibit there. I don't know where it is. I assume they must have put it out of sight somewhere, but hopefully one day the statue will come back out and you'll be able to look at it and enjoy it and revel in it, because again, this was a very great man, Benjamin Banneker. Now, as far as our other person that I mentioned, Nathaniel Bowditch, he was born in Salem, Massachusetts in 1773. That was the year of the Boston Tea Party. In 1806, he witnessed a spectacular total eclipse of the sun over New England, which lasted almost 5 minutes. And a year later, he collected reports of a spectacular meteor that exploded over western Connecticut. Now, he was offered the position of professorship of mathematics and natural philosophy at Harvard, and in 1818, Thomas Jefferson, of all people, offered Bowditch a post at the University of Virginia, and in 1820, Secretary of War John C. Calhoun offered a position to Bowditch at West Point. But Bowditch declined all of those offers on the grounds that, and this is a direct quote now, Bowditch said, quote, "I wouldn't fit in with those academic types," and yet he was probably just as academic, if not more so, than anyone at any of those facilities. Now, Bowditch's family had been shipmasters for over 100 years, so in 1795 he went to sea to merge celestial navigation principles with practical experience. The book that was most relied on by navigators of that era was a book called Moore's Practical Navigator, and it was published in Great Britain and England. Bowditch meticulously pored through this book, but found numerous discrepancies, and he let Moore know about them. This led to the publication of a revised edition, but that revised edition also contained many, many errors. So, taking the bull by the horns, in 1802, Bowditch decided that he would produce a book on his own, a new book, patriotically entitled The New American Practical Navigator. It exceeded 600 pages in length, was filled with detailed explanations, tables, maps, magnificent illustrations produced from copper plates. It became the Western Hemisphere's shipping industry standard for the next century and a half. Then in 1866, the United States Hydrographic Office purchased the copyright, and since that time, the book has been in continuous publication with regular revisions to keep it current. Bowditch's influence on the American Practical Navigator was so profound that to this very day, mariners refer to it simply as Bowditch. And a bronze statue of Nathaniel Bowditch is located at the Mount Auburn Cemetery in Cambridge, Massachusetts. I'm sorry about that. I skipped a few. Here you go. There's the statue of Nathaniel Bowditch. There he is right there. If you want to see it for yourself, it's located in Mount Auburn Cemetery in Cambridge, Massachusetts, and it also happens to be the first life-size bronze statue cast in the United States. Now we move on to another special gentleman, David Rittenhouse, who was an American astronomer, inventor, clockmaker, mathematician, surveyor, scientific instrument craftsman, and public official. Rittenhouse was a member of the American Philosophical Society and was the first director of the U.S. Mint. David Rittenhouse made a number of breakthroughs in importance to the United States. He helped establish the boundaries of several other states and commonwealths, both before and after the independence, including the boundaries between New Jersey, New York, and Pennsylvania. In 1763, Mason and Dixon began a survey of the Pennsylvania-Maryland border, but this work was interrupted in 1767. In 1784, the Rittenhouse and Andrew Ellicott completed the survey of the Mason-Dixon line all the way to the southwest corner of Pennsylvania. And in fact, here you see a marker there, which indicates to you that the survey establishing the Maryland-Pennsylvania boundary began in 1763. Indian Wars halted it for a time in 1767, and then continued to the southwest corner of Pennsylvania in 1782, and that marker apparently was erected in 1784. So in 1784, Rittenhouse and Andrew Ellicott completed the survey of the Mason-Dixon line to the southwest corner of Pennsylvania. Now, when his work as a surveyor ended, Rittenhouse resumed his scientific interests. I don't know why that keeps jumping, but pardon me on that. On October 3rd, 1769, Rittenhouse observed a very rare event, a transit of Venus across the face of the sun. Venus is closer to the sun than the Earth, and every so often, Venus will pass between the sun and the Earth and will appear, as you see down here in the lower left on the disk of the sun, as a circular black dot, not necessarily like an eclipse, but again, a dark dot which moves slowly across the face of the sun. And Rittenhouse took full advantage of that event, that transit of Venus in 1769, because the next one would not occur until the year 1874. So this transit in 1769, Rittenhouse used it to calculate the distance from the Earth to the sun. He discovered, using the observations of this transit, that the sun was 93 million miles from the Earth. That's actually the approximate average distance between the Earth and the sun. The published report of the transit was hailed by European scientists. Now here is a young lady. You've heard the old saying about breaking the glass ceiling. This young lady may have been the very first to do so. Her name is Maria Mitchell. And Maria Mitchell was an American astronomer, librarian, naturalist, and educator. In 1847, she discovered a comet. Now, if you were to discover a comet, or I were to discover a comet, it would be the name of the comet plus our surname. For example, if I were to discover a comet, it would be Comet Rao. If Bob Smith were to discover a comet, it would be known as Comet Smith. 3 people discovering a comet, that's the maximum limit for names, might be called comet. If you were from Japan, for example, Tago Sato Kosaka, Halley's Comet, Encke's Comet. But this was the first time a comet had been discovered by a woman. And so in her honor, this particular comet was known as Miss Mitchell's Comet. And in her honor, she won a gold medal prize for her discovery, which was presented to her by King Christian VIII of Denmark in 1848. Mitchell was the first internationally known woman to work as both a professional astronomer and a professor of astronomy. after accepting a position at Vassar College in 1865. She was also the first woman elected Fellow of the American Academy of Arts and Science and also the American Association for the Advancement of Science. Now, here's a guy who, if things had worked just a little bit differently, you would know who he is. I would mention his name. His name is Samuel Pierpont Langley, and many of you who are hearing that name might say to yourself, Samuel Pierpont Langley, who is that? Who is that person? You would know who he is, again, if things went a little different for him. He was an American aviation pioneer, an astronomer, physicist, who also invented the bolometer. He was the third secretary of the Smithsonian Institution and a professor of astronomy at the University of Pittsburgh, where he was the director of Allegheny Observatory. Now, toward the end of his life, Langley concentrated his efforts on building a flying machine. Now, his was the first successful heavier than air, unmanned, I want to stress that, unmanned flying machine, which was propelled by steam power. But when he attempted to build machines in which men were inside, they unfortunately suffered mechanical failures. The last of them in 1903, that manned attempt crashed into the Potomac just 9 days before the famous flight at Kitty Hawk, North Carolina. Had he been able to prevent the snagging of the launch catapult, Langley might have beaten the Wright brothers to aeronautic immortality. Now, remember, earlier I showed you the 15-inch telescope at Cambridge at Harvard College. Well, soon there would be construction toward the end of the 19th century of a new observatory in Williams Bay, Wisconsin, the Yerkes Observatory, which was begun in 1895, while the project was initiated by George Ellery Hale in 1892 and financed by Charles Tyson Yerkes. The actual construction of the building and installation of the 40-inch telescope, still the largest refracting telescope in the world today, that 40-inch telescope, the construction of it, and the completion of the observatory did not occur until 1897. The Yerkes Observatory in Williams Bay, Wisconsin, was officially dedicated and opened on October 21st, 1897. Here you see the observatory and the telescope as it appears today. The ceremony, the opening ceremony, included University of Chicago President William Rainey Harper and the observatory's benefactor, Charles Yerkes. On the 25th anniversary of this great institution, a number of famous scientists and astronomers came to the 25th anniversary of the Yerkes Observatory. One of them, I'm sure if you look carefully enough, stands out among all the rest. And that person, I'm sure you recognize, is this guy, Albert Einstein, who only came to this country for the first time in 1920. Now, Albert Einstein used a total eclipse of the sun that occurred on May 29, 1919, to prove his general theory of relativity by demonstrating that the sun's gravity bends starlight precisely as he has predicted. During the eclipse, astronomers photographed stars near the darkened sun and found their positions shifted ever so slightly, confirming the warping of space-time. Einstein's theory of general relativity suggested that gravity is not just a force, but a curvature of space-time caused by mass. Therefore, light from distant stars passing close to the sun should follow this curve and make the stars appear slightly out of place. This groundbreaking observation confirmed that space is not static. It's not a static flat background, but a flexible fabric. The verification brought international fame to Einstein and made him a celebrity scientist. Here's another guy who was important, another famous astronomer. His name was Harlow Shapley, and he was a pioneering American astronomer, famous for determining that the sun is not at the center of our Milky Way galaxy. And that revolutionized the understanding of our galaxy's size and structure. By studying globular clusters, balls of stars containing tens of thousands of stars, and special variable stars known as Cepheid variables, he placed our sun 50,000 light years from the center of the galaxy, and in turn vastly expanded the known scale of the Milky Way and other objects in the known universe. In the lower right-hand corner, you see the famous Andromeda Galaxy. The Andromeda Galaxy was thought to be 750,000 light years away. But today, we know that that galaxy is much, much farther away, 2.5 million light years out. And we knew it because of the studies of Harlow Shapley. Shapley literally doubled the size of the known universe with his studies way back in the early part of the 20th century, in the 1920s. Now you see the building of another observatory. This is the Great Palomar Observatory. This construction of the observatory began, and its 200-inch Hale telescope began in 1936, following funding secured by George Ellery Hale in 1928 and several years of design and mirror casting. The massive dome was constructed between 1936 and 1939, with the telescope's parts arriving on site in 1938. The final assembly was delayed, unfortunately, by World War II until 1948. The 200-inch mirror, that's over 5 feet wide, the 200-inch mirror for the Hale telescope was cast right here in New York by the Corning Glass Works on December 2nd, 1934, and then arrived at Caltech in Pasadena, California on April 10, 1936. After a failed first attempt, the successful Pyrex blank was shipped by rail across the U.S. in 1936, and then they spent 11 years polishing it before moving it to Palomar Observatory in 1947. The 200-inch mirror, did I say 5 feet? I meant 5 meters. That means the 200-inch mirror is actually 15 feet across. The Hale telescope at Palomar Observatory, the world's largest effective telescope for 45 years, from its dedication in 1948 until 1993. It was finally surpassed in 1993 by the Keck 1 telescope in Hawaii. Now we're moving into the space age. Here you see a view of Explorer 1. That was the United States' first orbiting satellite. It came after the Sputniks. January 31st, 1958 was when Explorer 1 was launched, marking the entry, our country's entry, into the space race. Developed by the Army and the Jet Propulsion Laboratory to counter Soviet Sputniks, it discovered the Van Allen radiation belts using an onboard cosmic ray detector. That 30-pound satellite stayed in orbit until it finally re-entered the atmosphere in 1970. And after we started putting satellites, unmanned satellites, into orbit, then came the next step, putting men up into space. Man you see on the right is Alan Shepard. He was the first American to go into space in a suborbital flight that lasted all of 15 minutes. He was launched from Cape Canaveral, went up into the atmosphere about 100 miles in space, and then came down in the Atlantic Ocean 15 minutes after liftoff. The man on the left is the first man to orbit, the first American to orbit the Earth, John Glenn. Glenn was the first American to orbit the Earth. He orbited the Earth 3 times in February of 1962. And after these successes of Shepard and Glenn, the President of the United States, President John F. Kennedy, decided that he would throw the gauntlet down and set a new goal for this country. He said, "We are going to the moon. Now is the time to take longer strides," he said. "Time for a great American enterprise. Time for this nation to take a clearly leading role in space achievement, which in many ways may hold the key to our future on Earth." And Kennedy continued in his speech to Congress, "I believe this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth." The address at Rice University, which you're about to hear on the nation's space effort, was a speech made on September 12, 1962 by President Kennedy. The aim was to bolster popular support for his proposal to land a man on the moon before the end of the decade of the 1960s and bring him safely back to the Earth.
But why symbols? Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
Well, indeed, after that proclamation, this country did indeed go to the moon before the end of the decade. And here you see the front pages of most newspapers. Here's the Daily News declaring when men walked on the moon. One small step for man, one giant leap for mankind. And you see on the front page there the two astronauts, Neil Armstrong and Buzz Aldrin, unfurling the American flag on the surface of the moon. How many of you remember that amazing Sunday night in late July of 1969 when hundreds of millions all over the world were glued to their television screens to watch as these two men on a ghostly, somewhat shaky television image, black and white image, cavorted and walked on the face of our natural satellite.
The EVA is progressing beautifully. I believe they're setting up the flag now.
You know, they started up behind time on this.
I guess you're about the only person around that doesn't have TV coverage of the scene.
Yes, this is the flag, not the core sample.
That's all right, I don't mind a bit.
I constantly doesn't mind a bit not having television right now.
How is the quality of the TV? Oh, it's beautiful, Mike, really is.
There it is, a U.S. flag on the surface of the moon.
Yes, indeed. They've got the flag up now, and you can see the stars and stripes on the winter. Beautiful, just beautiful.
That flag is on a frame. There is no wind to hold it out like that, of course. It's a 3x5 flag, and it's got a frame of its own to hold it out. Nothing more really is needed here, but it does seem that there ought to be some music.
Very good.
Hard to believe that event occurred on July 20th, 1969. 7 years to the day, on July 20th, 1976, this country did it again, landing not a man but an unmanned space probe for the first time on another planet, the planet Mars, the Viking space probe. And here you're about to listen to an NBC radio reporter who was located at the Jet Propulsion Laboratory in Pasadena, reporting on the moment when it was confirmed that the lander had indeed safely landed on Mars, and that we were, for the first time, not only hearing from a spacecraft, but also a spacecraft that would very quickly take photographs from the surface of another planet.
There is a delay between the landing and confirmation because of the vast gulf of miles lying between Mars and Earth, and so it takes 19 minutes to find out whether or not indeed the lander is on the surface of the red planet. Those 19 minutes have just about set. There you can probably hear the cheers. Touchdown is confirmed. The Viking has landed on Mars.
Pretty amazing. Again, 7 years to the day when we landed on the moon, July 20th, 1976. And here you see the first picture, or first photograph of the surface of Mars in glorious black and white, and then later, color photographs of the rusty red surface of the red planet. No, I don't see any Martians there. I see a lot of rocks. I see a lot of dirt and gravel. We're still trying to figure out from other probes that have since landed on Mars whether there was life in the way, way back beginning, millions of years ago, or whether there's life, primitive life, that's on the surface today. We're still searching. Stay tuned. The Hubble Space Telescope is a large space-based observatory launched by NASA in 1990 that orbits the Earth and provides us with exceptionally clear, high-resolution images and data of the universe in ultraviolet, visible, and near-infrared light. It is a pioneering tool that has fundamentally changed astronomy by allowing scientists to study distant galaxies, star formation, and planets without the distortion of Earth's atmosphere. And still another space observatory, the James Webb Space Telescope, the largest and most powerful infrared space observatory ever built, designed to look back 13.5 billion years to see the very first galaxies born after the Big Bang took place. Launched on Christmas Day in 2021, it is a partnership between NASA, the European Space Agency, and the Canadian Space Agency. Now here is a photograph that really should not exist. It was recently taken on April the 6th, 2026 by a camera mounted on one of the solar array wings of the Orion space probe. Remember, that was the spacecraft that went out into space with 4 astronauts, 4 human beings that traveled farther out from the Earth than any spacecraft had ever done, manned spacecraft. This particular photograph was taken not by a human hand, not through a window, but by a camera pointing back at the spacecraft from outside, from deep space, from 250,000 miles away from the Earth. And look what's in this single frame. On the left, you see Integrity, the Orion Integrity, the spacecraft carrying 4 humans, the first to travel this far from Earth since Apollo 13 in 1970. You see the famous NASA worm logo visible on the hull, solar panels catching sunlight. Whoops, hang on, bring that picture back. I'm not done yet. I don't know why I'm jumping the gun here with my button here. I apologize for that. On the right, you see the moon, its far side, the hemisphere that never faces the Earth, cratered and ancient, filling the frame with 4 billion years of impact history. And then in the far upper right corner, there you see it, that's us, a tiny bright crescent barely visible, Earth, home, 250,000 miles away and shrinking. 3 objects, 3 scales, a spacecraft, a world, a planet. This is not a composite. This is not a render. This is not CGI. A single frame taken automatically during the 6 minutes before 4 human beings disappeared beyond the moon and lost contact with the Earth for 40 minutes. The most profound photographs in history are often the ones nobody planned to take. Now, there are some people who to this day still believe that it's all a waste of time going up into space. Why do we go to space? Why are we doing that? Why did we go to the moon? To get a bunch of rocks? What did that do? Well, I'll tell you what it did. When was the last time you got on your computer at home or in your office? Your laptop computer or your desktop computer? When was the last time that you used your phone? I'm sure that a lot of you can't live without that particular piece of equipment, because it's not, of course, just a phone. It's a camera, and it can connect you with all sorts of apps and computer information. Or when was the last time that you looked on your big flat screen television at your favorite TV show, either you or your spouse or your kids, as they are now watching on this big screen TV, Sesame Street? All of these things and more that you enjoy today in the 21st century got their start in the 1950s and 60s during the evolution of the space age, the space race. All of these things came about through, again, the development of technology during that time. And now, all of these years later, all of these decades later, you are enjoying the benefits of the space age. Was it worthwhile to go into space? I certainly think it was. And to those who say, I saw the other week, I don't know how many of you have the cable service Me TV. On Sunday nights, late on Sunday nights, they rerun the TV show All in the Family. That show premiered more than 50 years ago. And in one of the episodes that they showed on Me TV, it was Archie Bunker and his next door neighbor, Mr. Jefferson. They were in Archie's house. Mr. Jefferson noted that Archie had an ashtray with the logo or insignia of the Apollo space program. And he tells Archie, he said, don't you think we should be spending this money better down here on Earth? Fight poverty, create a few jobs? Well, if Mr. Jefferson were here right now, I would say to him, Mr. Jefferson, at the height of the Apollo program and our race to go to the moon, NASA hired 400,000 people, the best and brightest people, to work for them and to develop the technology that we enjoy today. And space, is it worth it? Again, I think it is. How many of you out there watching me right now, if we were able to take the gross national product and reduce it to $1 single dollar, $1 for the gross national product, how much of that dollar do you think goes toward space? A quarter? No. A dime? No. A nickel? No. How about a penny? Does 1 penny amount to the amount of money that we devote toward the space program? Believe it or not, no. A half a cent, that's all. So out of that $1, we're using a half a cent to explore space, develop space age technology. Is space worth it? I certainly think it is. And I think now that you've heard my case here, I think you too will agree that space is or was worth the effort. Anyway, I want to show you some calculations here. 186,282 miles per second. That's how far a beam of light will go in a single second. The speed of light. In 1 minute, that light beam has traveled 11,176,920 miles in 1 minute. And in 1 year, that light beam has gone 5,878,487,000,000 miles. It's a heck of a lot easier to use celestial shorthand and take that big number of almost 6 trillion and reduce it to one light year. That's what we call a light year. It's not a unit of distance, a unit of time, it's a unit of distance. So instead of using all those zeros, we simply say 1 for 1 single light year. Well, we know, and we noted at the very beginning of this presentation, this is the 250th anniversary of this country. So you may ask, how far away is 250 light years? 250 light years is the equivalent of that number that you see there, which is 1,460,962,200,000,000 miles. That is how far out in space a light beam would go over a span of 250 years. And you could do something that only a stargazer can do. You could look back in time at night. Take a look at the sky. Look for the Big Dipper. There it is, up there. 4 stars in the bowl, 3 stars in the handle. Now, extend a line through the handle of the Big Dipper. Stretch an arc, if you will, and that arc will lead you to that bright orange star, Arcturus. And then after you find Arcturus, continue the line. In other words, you speed to Spica. Let me give you another viewpoint here. We arc to Arcturus, we speed to Spica. Now, Arcturus is relatively close to us, only 36 light years away. But Spica is located 250 light years away from the Earth. In other words, when you see Spica right now in our sky, you're looking backwards in time at light that started on its journey toward the Earth 250 years ago at the time of the adoption and later the signing of the Declaration of Independence. So, for this year alone, 2026, I would suggest instead of calling that star Spica, maybe we should call it, in honor of this country, America's star. So, that is the story of astronomy and space over the last 250 years. And there you see the gentleman who made it all possible, again, all of those years ago. I'll leave you with this. Benjamin Franklin, he had shocking ideas. John Hancock signed big time. Alexander Hamilton never threw away his shot. The founders inked history. They framed freedom perfectly. They were all rebels with a clause. They had quill power. They had bold declarations. They were all star-spangled smart. And they made history, in this particular case, ponderful. Thank you very, very much for sticking around for a little over an hour and listening to me blither about the history of this country and space and science. And now if you have any questions that you'd like to ask,
Say
try to
thank you.
unmute yourself or you can put your question
Yeah,
on the
say
chat.
thank you. Hey, say thank you.
Just say thank you.
There was a question in the chat. Did the British Mariners adopt Bowditch's work when it was published? And I think I
Yes.
know the answer, but did British Mariners, when, I guess, did they? Was it immediate? Was it?
Well, I know that, as I told you, um, um, it was pointed out to Moore, who made the first celestial practical navigator, that his book had discrepancies. And even after he revised it, there were still discrepancies. I'm sure that not immediately, but shortly thereafter, the American practical navigator came into use for not just America, but also for navigators worldwide. And again, even to this day, no matter where you go, Bowditch is the book that is used for mariners and navigation.
Okay. That's all that's typed in. So if anyone else has any questions that they would like to ask, this is your chance. A lot of excellent presentations, stellar presentations, stellar. Bravo.
Thank you. Thank you. Thank you.
Yes, thank you. I was fascinated.
That's good.
If that be the case, if there's no other
Thank you.
questions,
Yeah,
thank you
don't
very
see
much.
it. All right, thank you, Joe. Have a good night.
Thank you.
Thank you for tuning in.
Have a good one, everybody.
Okay, good night.